Now I'm live. All right. I didn't have auto start and auto stop on. Here we go. How's the sound? All right, so now I'm streaming. All right, let's give this another shot. Coming over here, I'm gonna delete. Oh no. I'm streaming in too many places now. All right, here we go. So nice work on getting the discussion posts up and the GitHub fork links up. The next step is, so let's take a look at our calendar, just like the logistic update. Next step is getting homework 1 done on tomorrow, so for Thursday, and then on Friday I'll review it and get grades back before the weekend. And then there's this reading coach for module 1, so let's take a look at this. If you go to that link, it'll take a second, but it'll show you that like Ryan Cooper made this Copilot Studio learning coach. So if you open it, it gives you two options, two like kind of topic options. You can either learn more about module 1 or do a reading quiz to kind of test what your knowledge is of module 1. So as you're working on the homework, this should be a good resource for helping interpret Python code. The Copilot and then ChatGPT and a few other AI models, they have a lot of Python code examples. So they've been really helpful in debugging Python code and getting things to work. So you can paste in like errors that you get, or you could paste in like starter code of like, hey, how do I get to the next step? I'm trying to plot something. Or how do I, if you're asking a question about like, how do I add axes labels or something like that? We're not really, I don't think we're plotting anything in this example, but so you can learn about a topic. And then the thing that I want to see on Friday is this reading quiz. And I'm really interested to know how these learning coaches, like how these AI tools help or hinder, like if they're not helpful. Those are great lessons to see about like, all right, I tried to ask it about a topic and it's getting started, but it gave me nonsense. Like, here, let's look at this one. Let's grab source of round-off errors. Let's see if it gives us anything here. Okay, so this is kind of a cool, so this is smaller than the smallest number that you can add to 1. So when you try to add it, you're actually going to get an example. How do I copy this one? Go to line, display options, copy code. There we go. So if I copy this in, try to paste it, I'm importing NumPy. I'm creating 2 variables, A and B. I'm going to add them and then check is result equal to A. And it's going to say true, even though I added B to A. And I could add B to it as many times as I want. For I in range 1000. Let's do this. We'll say result equals A. Then we'll plus equal. So even though I'm adding 1,000, and I can do it, so here it's 10 to the 16. Even if I add it millions of times, like maybe you thought it's just because 10 to the negative 16 is too small, like you have to add more to it to get it to not be 0, not be adding 0. But 10 to the negative 16 is smaller than the smallest number that you can actually do floating point. It's called floating point operation, so adding, subtracting, dividing. It'll take a few minutes to figure this out, but it'll still tell me that it's true. So that one's kind of a cool example here. Dive deeper. Anyway, so try out that learning coach. See if it's helpful. Like, where does it help you? If you are finding it helpful or it's not helpful, the discussion posts, these, oh my god, coming up here, add a discussion post and say like, hey, I tried this out and this was my prompt. Here's the output. Why is it doing this? Or isn't this cool? That would be a great place. I would love to see more examples of like how it's useful or how it's hurting in your learning journey. All right, so that's the logistics. Is we've got reading assignment for Friday, homework 1 on Thursday, and then next week we'll jump into our first project for module 1. So we're already up and running. Hopefully readings are making sense and all of that's going well. And also, so getting to this homework, let's go back into our course, and I'm gonna pull up the course syllabus. So in the syllabus, you have a copy of this computational mechanics website in your own GitHub repository. You don't have to do anything with that GitHub repository. Like, it's just meant to be a place where you, like, quote unquote, bought the textbook. The textbook is free and it's all online here. So let's go down to the homework in module 1, and here there's stuff here, but I can't edit anything. If you want, you can download any of these homeworks or projects as notebooks or markdown files and then work on them on your own version of Jupyter. I tried to make it easier to get up and running with Python and Jupyter by creating this NanoHub link. So if you click on Jupyter Hub, it'll bring you to this computational mechanics open educational resource. And now you can say, all right, launch this tool. Get me into Jupyter. And if you are, so I gotta stop this. Let me log out. Because really, if you haven't used this before, what it will tell you is that you must log in. So as I try to launch it, it'll tell me like, hey, you need to sign in. If you don't have an account or there's nothing there, then you can click that sign up. And here you can use a Google account, or the other option is create a NanoHub account. Don't use this university credentials. It just doesn't work for some reason. So sign in either with Google or with your own, like, create a NanoHub account. You can use your UConn email here, or you can use, if you're coming from a different school, you can use any email there. NanoHub has a ton of awesome tools and resources. So after this class, you'll have access to this forever, and you can, here, let's go explore. There's new stuff, new tools. Let's see what's new. Yeah, all sorts of calculators and smartphones, summer URE guide, anyway, all sorts of stuff. Okay, so I was going back and forth, but let's get back onto NanoHub. It'll tell me to sign in, so I will sign in. Just pasting in my password. And I think I already have this one up and running. So now I'm up and running. Here's get me back to the syllabus, so that'll bring me back to the website. But if I want to go into homework 1, here's the first reading, second reading, third reading, and now homework 1, I can skip right into that. Or I can open up any of those other readings. Like if I want to go and read more about interacting with Python, and not just read about it, but actually try to edit things. So here I change that hello world to hello Mr. Bond. And I can come down here, change it this one, so 2 plus 3, like, okay, it works. But anyway, so I just wanted to, for today, just jump into homework 1 and give this a shot. First couple lines are just, these are things that I import on the top of all of my notebooks. We're not really plotting anything. We'll use NumPy a little bit, and then let me delete this because I just want to start from scratch. So problem 1, part 1, problem 1. I want to calculate the volume of this box. So I'll say V is going to be my volume. It's 12.5 times 11 times 14. And I run that code and I get nothing. This is sometimes confusing for people if it's either been a while since you used Python, or if you're coming to Python for the first time. If you are, welcome. It's a great world in here. We're happy to have you. I'm a big proponent of Python. I love like open source software in general, and Python's a great like machine learning and scientific software. And it's a great glue language for all sorts of engineering softwares and all sorts of great stuff. So anyway, Python's great. Keep using it. So nothing happened. What I want to do now is actually print that output so I can see what happens. Another way that I could do that is just, if I define a variable, the last line of, this is called a code cell. So this code cell, the last line will get printed as output. But I mean, it seems like the last line was this, but when you assign a variable, the default is that it does not show up. So I can ask for it and it'll show me what it was. That doesn't really give me a lot of information. Like these 3 numbers multiplied, that could be anything. So for me, what I would want to do is say like, all right, well, I know it's inch times inch times inch. So this volume is an inch cubed. So let me format that output a little bit. Print volume of box in A is, and I got to put this as A. And I saw some people using these squiggle brackets like this, and that's kind of a nice way to format your variables into the actual outputs. And so if I just do that, let me see, is it R? No, F? There we go. So if I put an F there, then it'll format those variables as outputs. The way I like to do, the way I usually do it is just put squiggle brackets and then write dot format of V and give it that variable. Whether you put the F at the beginning or a dot format at the end doesn't really make much of a difference. But when I'm looking at this, I see this extra .0. That's an extra significant figure that doesn't really exist, because really this is 12.5 by 11 by 14. 12.5 is probably 12.5 plus or minus a quarter, right? Like it's not 13, it's not 12, it's somewhere in between. So I don't think I have I don't think I have 5 significant figures. 4 is really pushing it. So Really 3 would be about right, but let me at least like change this up. Let's go 0.0 floating point, and now it'll show that one. Can I say 3? 2? No. But it'll chop off that last dot 0 here and show me just the volume of the box in A. So I mentioned that this is like a code cell. Some of the structure of Jupyter notebooks, again, like if you haven't been using Python and Jupyter, this is all new, and new and exciting is the main thing that I think that I'm excited to share this with you. I love Jupyter notebooks because I can have code that does what I want it to, but then I can also have these other blocks called markdown blocks, and those are describing what I'm trying to do. So in this case, where we have a homework problem, it gives you the actual questions that you're trying to answer in this markdown cell. And I go here, and so I'm holding Alt, hitting Enter. You can also click this Run button, and it'll run it and move on. But I could also create my own markdown here and say, in the same way that we make we're making comments in Markdown on GitHub discussions, I could add a question here, like for this part B, maybe should density be in kg per meter cubed, or can I keep it in LV per IN cubed? And that one, you don't have to ask that question. I can answer it now. Like, do density however you want, just keep the units so that we know, is it pounds per inch cubed or pounds per foot cubed? What are we dealing with here? But that's an example. These like markdown cells that you add with like questions or comments, they really help me give better feedback as I'm looking at your assignments. And every assignment you can resubmit as many times as you want. So if you're working on this and you feel really stuck, go through and just put questions in. Like, you don't have to have code especially when you're struggling. Like, I noticed a lot of people in our GitHub discussion said the thing they want to work on is coding. So if you're struggling with the code or errors that you're getting, you can leave the error, add a question of like, why is this happening, or how can you help me here? Then I'll add some feedback, resubmit the work, and get those points back. So there's no penalties for resubmissions. You can resubmit the homeworks and the projects for all of this. Cool. Okay, so we have like problem 1, part A done. I added a question. Maybe I'm stuck here. I want to turn in something, like maybe it's 11 o'clock at night and I just want to turn in something before the deadline. And that's okay. I'd rather you turn in something than nothing, or at least give me an update of like, hey, I'm halfway done. Give me another couple hours and I'll submit that tomorrow morning. But keep me updated. What's the current status? So if I want to submit this work, I can say File, create a print preview. And the print preview brings me to, really this is like an HTML website of all the work that I had just done. So it shows me the work, it shows me that printing, it shows me the output here. It even has my question that I just put in there in my new markdown cell. And then everything else below is all blank because I haven't gotten to it. And that's okay. So I'll hit Control P and it'll say save as PDF. So I'll save that as a PDF, homework 1, and that's okay. I'll overwrite it. And that PDF that I just saved, I can put that onto Husky CT. And that's how I would love to just do interactions with only Jupyter notebooks, but Husky CT, a much better interaction, like way of commenting, is using PDFs. So that's what we'll stick to for now. Cool. Cool. So that's the homework. Oh yeah. So if you're downloading these as notebooks and you want to run them on your own computer, you can do that. You can even run it directly from your, here, if I go to the code and I look at all of these, so I have like different forks of this. I could download, I can clone this, or I could download this whole branch here, and I could work within my own little computational mechanics folder on my own desktop. But usually what happens is, so I was just working inside this Jupyter notebook. Let's say I want to save this one, so I'll say file, but there's no like print preview button. There is this print, so let's see, and that one's okay. So you could try that print button and then save that directly as a PDF. The other way that works pretty well is you can export as HTML, which is what the print preview is doing. It brings it into an HTML. I'll open it up with Google Chrome, and now it's showing me that the same work that I had just done as a web page. And Control P, or if you're on Mac, Apple P, it'll bring it up, and you can save that as a PDF. So if you're working on your own computer, great, go for it. But you might have to do like a file export as HTML and then save that, like print that to PDF. Cool. All right, other thing that I wanted to kind of go through was I noticed some great discussion posts here in our first discussion, kind of getting to know each other a little bit. And all of these, it's okay not to say like who you are and personal information. Like it's an open discussion forum. But I added some comments here, but there were a few things that I wanted to talk about. So one thing I noticed was that these things were called like a list. So let's take a look at this, because this is kind of, it's like a nitpicky thing. Oh yeah. So when you create it, technically it is a list of numbers, but these things here, let's make this. So X is 1463572. It is, if I look at the type of X, not type E. Let me zoom in a little bit so we can all see it. It's called a tuple. A tuple is not a list, and there's one very big distinction between a tuple and a list. So when I try to say that Y is going to sort X, it's telling me that I can't sort it, like attribute error, there is no sort. So maybe I need to say sort X. It's still telling me sort is not defined. So let me call this X tuple, like XT, and then I'm going to call this X list, XL. So now XL is a list, and XL dot sort that's weird. It's telling me that Y, so XL dot sort. And yeah, so there's like there's a lot of weird things happening in these kind of lines of code. So and the reason I'm bringing this up is not to say like, haha, you gotcha, like you're not a Python expert. It was more like, wow, this is some weird Python and they're not bugs. Technically, these are like features, but sometimes features really feel like bugs. So a tuple, when I try to sort a tuple, xt.sort, I can't do it because tuples are what's known as immutable types, so they're not changeable. Once I tell Python, like, hey, take these 1, 2, 3, 4, 5, take these 7 numbers, store them inside this piece of the computer and call it xt, I can't do anything with that anymore. I can make copies of it somehow and then maybe change that, or I could change the type, like create a whole new variable, kind of like this, where I'm saying like, all right, XL is a list here. I could probably turn this into a NumPy array, and then I could change it. But a tuple is meant to be this like static thing. Like it's not going to change. I can't rearrange it. I can't say like, oh, whoops, this 4 was actually supposed to be an 8. So x1 equals 8. It's going to tell me like, no, you're not allowed to do that. Okay, so that's the first thing. A tuple is a tuple. Once you set it, it's set and done. The next thing is like, all right, well, let me make it a list then, and I want to sort the list and save it as a new variable. This xl.sort is sorting the actual variable xl. So when I tell it xl.sort, it's sorted. And when I try to say like, okay, set y equal to the sorted thing, it's telling me like, all right, well, y does not exist. That's a weird, it's not an error. It's not telling me that I can't do that. It's just showing me that there is no XL that's sorted, but the XL that is sorted is showing me that, so I lost the order. And this is kind of a cool example of like, what's the difference between lists and tuples is that the tuple will always maintain this order. The list, if I reorganize the list, it's reorganized. It's gone. It does not preserve the original order other than like the code that's above it. Yeah, so, and I'm trying to think what I could have done. So if I want like the XL and the XL sorted, what I could say, let me delete this. I could say y is XL and then y dot sort. So now I have to run this. Oh, no. So because I'm saying y is XL, it is this set of numbers, right? Like so I created a list. I tried to create a new variable. So really what I need to do is say y is a copy of XL, and then sort y, and then print out these things. So first I need to run, let's put all this, I'm just merging these so that it's all in one spot. Okay, so now XL is created, XL is copied into Y. Now I sort Y, and then I can show like, okay, this was the original list, here is the sorted list. Whew, weird, right? And yeah. And then even weirder is that tuples, they can't be sorted at all. They're always, so one way that I could have done this is just, I sort the list, but leave the tuple. Like I have a tuple and a list. The tuple will always maintain its original structure. The list, I can change around the order. I could even sort it backwards if I wanted. Yeah. All right, so that was it ended up being a longer discussion than I thought, but it's kind of a cool, kind of weird and cool example in that case. So thanks for sharing that, because And here was another one. I won't do too many because I don't want to spend too much time. So here was another example where where this person was creating like a linear function and trying to find what is the best fit curve. This is a really common thing, especially as engineers, that we have to do, and especially for linear functions. But I wanted to show one other way of doing this, and also every time you do a curve fit like this, always plot your data and plot the curve fit, because otherwise there's no other way to tell, is it a good fit. That's the best way to figure it out. And this is a great example of like using built-in Python functions to accomplish a task using this curve fit. So importing SciPy optimized curve fit. But what is curve fit doing? Like, why does it need linear func x data, y data? What are those values? Let's run it. It works. I don't get any errors. But what the heck is this thing? So if I want to know what something is, put a question mark at the end. And now what it does is print out what's called the doc string. So all the documentation that people had been working on. My favorite part of doc strings are the examples at the bottom. So here it's showing me like, okay, if I have a function that's an exponential decay with an offset and like some kind of magnitude to it, some kind of initial value and an offset, then I can do this curve fit this way. And again, like they're plotting this data, right? Like they're not, you can't do a curve fit without a plot. So anyway, so I really like those examples at the end, but let's look at the very top of this doc string to see what the inputs are. So f is a function where it has one input, like x, so some independent variable x, and then parameters that define that function. X data are those independent x variables. So usually it's like x values, or time is usually a good like independent variable. And then y data are like the measured things that I'm trying to say, like f of x or f of t, like some kind of function. And then there's these other things that I can plug in there, but those all have default values, which I can see from here. P0, sigma, check finite, all that. Those all have like default stuff. Cool. So it seems to be working, but let's make sure that it does work. So I'm going to import matplotlib, my PLT. I like to use this 538 plot style. And let's plot my x data and y data. We're going to put it as like circles. I like to do multiple lines like this. So I can say marker size equals 20. And then I want to look at my x data. And now I want to take this linear function, plug in my x data, and give it these two mfit and bfit values. And let's show that as like a red line, like that. And zooming out so we can see it all. And here I can see these dots are the actual data that I was trying to fit, and my red line seems to be the best fit. Like it seems to be going through all of those data points. So it looks like that's a good fit for this. And oh, the other thing I just wanted to say about that, when I say curve fit, look at this, is the very first thing it says about this is that this is a nonlinear least squares function that can fit f to my data. So it's nonlinear, but this is very much a linear function. and we'll revisit this in module 2 and module 4 when we start looking at like data and best fit curves and data processing like that. But I wanted to show one other way of doing this with NumPy, np.polyfit x data y data. And what this is going to do is make a polynomial fit from my x values and y values here. And I want to make a first order polynomial fit. And now I get the same two values that I got up here, 2.01, 0.07. And that makes sense. Like whether I use a linear or a nonlinear curve fitting function for a linear fit, it's probably going to be the same. There's going to be some weird cases where, like if this was higher, if I'm trying to fit like a third order, not 31, third order polynomial or something, like maybe, and I'm trying to do that up here for the nonlinear one, maybe it won't work. But for first order fits, whether it's linear or nonlinear, it's kind of 6 of one, half dozen the other. Technically, this polyfit will be a lot faster. When I say a lot faster, I mean like nanoseconds instead of hundreds of nanoseconds. So again, as an engineer, as a mechanical engineer, it doesn't really matter to me. But if you're trying to do this fit often, like you need to run it, like make predictive functions, and you're trying to fit a linear function, it might make sense to optimize it with like a polyfit rather than a curve fit, like a nonlinear curve fit. That's like a nitpicky, it's not a big deal to use one or the other. All right, cool. Then let's take a look at, what else did I see? There was this, there was another thing that came up. So we have, let's look at this one's kind of like Python gotcha, but also like a Jupyter gotcha. So what we have here is that this person was taking their heat transfer ideas and plugging it into some code. So we have the Fourier's law defined at the top, and these variables for Q are like K, T1, T2, L. But when I try to run this code cell, it's going to tell me that K is not defined, even though it's very much defined. Like 2 lines down, it's right there. Like why can't Python just figure out that it's right there? And the reason is that we're running from top to bottom, like line by line. So what I could do is comment this out and then run it, since I have this same line down here, like the same formula is right there. When I run this, it gives me the heat flux that is supposed to be there. And now I've run that code, it has output. If I uncomment this, now it gives me no error, because all of these values were already stored into what's called the namespace. So my Python kernel, like the thing that's running Python, it's keeping track of all of these values. If I want to look at what's defined, I can say whose, and it's going to show me like, hey, you've got L defined, there's a T1, there's a T2, you define this list, you define that tuple, there's another list here, there's another array, like NumPy array down there. So I could take a look at like what's defined. If I restart this kernel, restart, and I'm gonna split that into, so I took these two things and split them into 2 different cells. I need to go back to the top and run from the top down. So run, 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 run. Oh, that one, I forgot that this one was running forever. I never checked the output either. Let's just change that back to 1,000. Still true. There we go. Here we go. running. My plot works again. So the last input was 7. If I try to run this one, K is not defined, but I can run things out of order, which is both a feature and a headache in Jupyter. So I run this. Now K is defined. I can come back up and run this. So I went 11 and then 12 above it. Now it works, and that one works. But I have to run this one before I run that one, or I have to comment it. Like make sure that anytime I use a variable, it's always defined above where it gets used. And you can always check to see, like, all right, did I actually define it with this, like, who's, WHOS, who's here. Cool. Yeah, thanks again for sharing these examples and for sharing like some your favorite summer places. It's cool. I like the beach. I love being outside. I spend a lot of time like biking, either mountain biking or road biking. As it gets hotter, I start road biking more. But yeah, and then the beach is definitely where I want to be all summer. And that's it for today. So we're working our way through computational mechanics, and we'll keep chipping away and keep learning along the way. All right, thanks a lot. Keep sharing your work, and I'm looking forward to Friday.